In this lab, we will continue with the data visualization using interactive plots in Plotly. We will try similar bubble plot on the household travel survey data. For each dwell type, let's look at the columns of this household travel survey data. It is household ID, household structure, dwell type, on dwell, household INC group, household size, years lived, total bikes used, total VEHS, adults, age 5 to 18, tertiary education, secondary education, primary education, full-time, part-time, casual, total work, total trips. Now for each dwell type, we will plot the bubble type of household size versus years lived, where the size of the bubble shows the total number of trips made by that household. Let fig equal px dot scatter of this household survey data, comma, x equal household size, and the y equal years lived. So the vertical axis will show the years lived. Size, the bubble size is shown by total trips, and color equal the color of the bubbles is dwell type. Facet underscore column equal dwell type. So each of the column facets will be a dwell type. Hover underscore name equal dwell type. So the title of each data information will be titled by dwell type. Log underscore x equal false. So the x-axis will not be in the log scale. Fig dot show open and close bracket. So we have so we can see that the x-axis is labeled household size, and the dwell type is for each of the facet column, and the dwell type are separate house, which is blue, terrace or townhouse is shown by red, flat or apartment is shown by green, and other is shown by purple, and years lived. So we can see for the separate house, the household size for 0 to 2, the years lived is much higher. And for the household size 6 to 8, the years lived is less than compared to other household sizes, and the bubble size, which represents the total number of trips made by the household, is much higher for 6 to 8 household size. So we can see that for 0 to 2 household size, the number of trips made is less, much is less than compared to the higher household size. And for the dual type terrace or townhouse, we can see for the household size 0 to 2, the years lived is almost the same, about 20 to 30 years, about 25 years. And the total trips made is shown by the size of the bubbles, and we can see that uh, there are bigger bubbles which show more total number of trips made, and the smaller bubble shows less number of trips made. And for the green ones, as we can see that for the 0 to 2 household size, the years lived is about 30, 31 years, and the bubble size shows the total trips made, and we can see the larger the household size is, the years lived is much less, and there is more total number of trips made. And for the household size, uh, for the purple one, which represent other types of uh, dwells, um, the household size for 0 to 2 shows that highest number of years lived. And for household size 4, we can see the total trips made is 12, and years lived is around 11. So all this graph shows that for 0 to 2 household size, the years lived is much higher than compared to the bigger household size, and the number of total trips made is smaller compared to bigger household size. Now we look at animating the data plots. Data animation against a continuous variable could be a helpful tool to add another dimension to the plot and see the values of pattern change with respect to the animator's value. Let's load the gapminder data from the plotly and use animation frame to show the changes in life expectancy and GDP per capita in each continent. Let countries data frame equal px. Px represents plotly.express library. px.data.gapminder open and close bracket. And the country's data frame looks like this, where the columns are country, continent, year, life expectancy, population, GDP per capita, ISO, alpha, ISO number. Let fig equal px dot scatter of country's data frame, comma, x equal GDP per capita. So the x-axis shows the GDP per capita, and the y equal life expectancy. So the y-axis shows the life expectancy, comma, animation underscore frame equal year. So the scroll bar which shows the animation underscore frame represents the year, comma, size equal GDP per capita. So the size of the bubbles will be shown by the size of the GDP per capita, comma, color equal continent. So the color of the bubbles shows the continent. Fig.show. Now we can see that the color blue represents Asia, is for the continent equal Asia. And the year is 1952. And GDP per capita equal, which is on the x-axis, and that is around 108.382. Life expectancy is about 55.565. The red ones, we can see that they show the highest life expectancy, and that's for the continent Europe. and year is 1952, and GDP per capita is um, around 9,600, and the life expectancy is around 72, from say 65 to 72, from 60 to 72. The highest is here. And the green ones, which are over here, this is for the continent Africa, and this is in the year 1952. GDP per capita is around 1,000. Life expectancy is the lowest is 30, and the highest seems to be uh, around 50. So for Africa, it's quite low. For the continent Asia, GDP per capita is around 9867, but we have more than 100,000 as well in the same year. So this is continent, but this is for different countries as well. So so each continent, Asia, for example, has Afghanistan. If I want to find out which countries are there, let me see. Cell above. So, so we have DF countries, and we want to subset country and continent. And we do value counts of this. So we can see that country Afghanistan, let's do let's do let's do the other way, group by continent. Let's do group by continent and show country and continent. We have to remove the dot. Double square bracket. So we can see for the continent Africa, we have countries, 5 countries, and the count is 12 for each of them. And we have continent Europe, and we have Switzerland, Turkey, United Kingdom, and these 2 dots in between show that there are other continents as well. So let's transform this to a data frame. Dot to underscore frame, open and close bracket. And let's see, and then we want to pull out the continent Asia, continent let's run this. This should give all the continents. Let's see. No. So to frame, this will give us the data frame. Let temp equal to this, temp equal to this. Let's run this. And then let's from the temp data frame, let's subset where temp continent equal Asia. Continent. Okay. Gives me error, so let's just let's see temp continent. Gives me error. So let's see, we'll reset index. Reset index in place equal true. Let's see. Let's print temp. Okay, so we have temp, we have reset the index. Now we want to subset from temp. We want to subset continent equal to Asia. Okay, so previously we were not able to do it because the continent was in the index. So now the continent is in the column, is one of the columns, so we can subset. So now we can see that all these countries are coming under continent Asia. So the countries are Afghanistan, Bahrain, Bangladesh, Cambodia, China, Hong Kong, India, Indonesia, Iran, Iraq, Israel, Japan, Jordan, Korea, uh, Korea Republic, Kuwait, Lebanon, Malaysia, Mongolia, Myanmar, um, Nepal, Oman, Pakistan, Philippines, Saudi Arabia, Singapore, Sri Lanka, Syria, Taiwan, Thailand, Vietnam, West Bank and Gaza, Yemen. So these are all the countries coming under continent Asia. So that's why we have uh, we will have the bubbles representing each of the countries. So in the next one, we have a animation frame over here, and the ears are representing the animation frame. So if I click on 1957, then we can see that this is the data for 1957, and still for the continent Europe there is very high life expectancy, and the GDP is still less than 20k for Europe. And for the Africa, the life expectancy is still low. But one of the countries in continent Asia is showing very high GDP with the life expectancy of around 58. And that is in year 1957. Let's look at 1962. So in 1962, we can see that this country which had highest GDP is now the GDP is decreasing, and the life expectancy is increasing. And for Europe, the life expectancy is increasing, and for Africa, the life expectancy is also bit higher, but still low, still the lowest. Let's look at 1967. We can see the the GDP, the Asian country which had highest GDP is now decreased, and the life expectancy is a bit higher. But for Europe, it's still higher, and for Africa, the life expectancy is increasing. And for Europe, the GDP is increasing as well, slowly. Let's look at 1972. So we can see that for Africa, the GDP is slowly increasing, and the life expectancy is also increasing. And for one of the Asian countries which had highest GDP, the GDP has increased once again in 1972, and the life expectancy is also increased, and the GDP for all the countries are now increasing slowly. For 1977, we can see yes, so the GDP is slowly increasing, and the GDP for the Asian country that was highest is now decreased, and the life expectancy is increased as well. Let's look at 1982. The GDP has decreased quite a lot, and for the country having the highest GDP, the life expectancy has increased as well, and we can see that all the countries are having GDP below 40,000, and the life expectancy is also increasing, including for Africa. 1987, the life expectancy is increased again, and for Africa also is increasing slowly, and the GDP is all below 40,000. Let's look at 1992. We can see that the GDP is below 40,000 and the life expectancy is slowly increasing. For 1997, we can see that the GDP is slowly increasing and the life expectancy is also slowly increasing. For 2002, let's see, for Africa, yes, so the life expectancy is increasing again, and the GDP has decreased for all the countries. And for 2007, the the life expectancy has increased, but the GDP has increased as well. Okay, let's add another parameter here. Another column has the hover underscore name equal country, and this will show the country. So here, if I click on each of these, so this big circle is for Kuwait. And Kuwait was having very large GDP but low life expectancy, and in 2007, this is Bahrain. So Kuwait has disappeared, so which means that it has much higher life expectancy, and African continents is still having low life expectancy. And for now, we will add another column, we will add another parameter called facet underscore call, and that equals to continent. So each of these columns represent different continents. For Asia, for Europe, for Africa, for continent America, for continent Oceania. Let's look at 1957. So we can see that the life expectancy is for the Asia is from around 40 to 70, and for Europe is around 50 to 75, and for Africa is around 30 to 60, and for America around 40 to 70, and for Oceania is there is only one country. There is two countries, so the life expectancy is around 70, and this is in 1957. Now it will be good to know for the latest year, which is 2007. What's happened in 2007? So the GDP per capita has is still below 50K for Asia, but the life expectancy has increased, and for Europe as well the life expectancy is increased, and for Africa is slowly increasing, and for continent America it has increased as well, and for Oceania it has increased. So our life expectancy axis um, uh, uh, is not enough to show that. So let's mark the x-axis scale to be log underscore x equal true. Let's see what happens. So now the x-axis is a log scale now. So let's see if 2000 shows some figures. So in the normal scale, the 2000 in 2000 Oceania was not showing anything, but in the log scale, the Oceania is showing some values. So, these are the countries: New Zealand, Australia. Um, so the life expectancy has increased. It's 80 and 81, and the GDP is um, increased as well. And for America, the life expectancy is also increased, and the GDP has also increased. And the top one is the Canada. The life expectancy is much higher. So Japan, the life expectancy is 82. So for all the countries, the life expectancy has increased. Okay, now we will add one more. Size underscore max equal 45. So this will show that the maximum size of the bubbles can be 45. So we can see for the Kuwait over here, life expectancy is 55 in the year 1952. And the highest life expectancy seems to be for Iceland, which is 72. Let's look at what happened in 1957. So the life expectancy is slowly increasing for all the countries. 1962, so the life expectancy is slowly increasing, still increasing. And for all the continents, the life expectancy is increasing. And for 1972, the life expectancy is increasing again. 77, yes, so is increasing. So we can see that it's increasing. Still increasing. So in 2007, we can see that it's quite high. So let's see, we add another parameter, say range underscore x equal from 100 to 1 million. So let's see what happens. 1952 doesn't show us anything. What about 1957? Doesn't show us anything. 1962, 1967, 1972. So doesn't show us anything. We need to add the range of y. So range, we add the parameter range underscore y equal from 30, 90. So now we can see the values. In year 1952, the life expectancy um, is about 65. Kuwait is 55, and this highest one is Israel, which is 65, and this highest one is Iceland, which is 72. And Australia is 69. In the America, the highest life expectancy is for Canada, which is 68. and the life expectancy is increasing as we go from year, as we uh, progress. Now in year 2000, we see that uh, where Israel was the highest, having highest life expectancy in Asia continent, now Japan has the highest life expectancy of 82. In Europe, Iceland has the seems to be having highest life expectancy of 81, and in Africa, um, reunion country seems to be having life expectancy of 76. Canada is having highest life expectancy of 80, and Australia is having highest life expectancy of 81. Okay, so in the next lab we will look at the cars data.